I'm using GitHub Copilot to rewrite a .NET framework application in Visual Studio 2026. And this section is going to be the data access with Entity Framework. Now, data access code can get very repetitive, especially if there are a lot of entities or database tables. For each entity, the process is typically creating a repository, adding the entity to a DB set, configuring some fields with a DB context, having some basic CRUD queries in the repositories. If a repository is being used, most developers are also going to use the unit of work to commit their transactions. These, meaning the repository and the unit of work, they're typically going to need a DB context to be injected. Now, the other part of setting up just doing one entity, the setup process, is to ensure that all the dependencies are configured in a DR container. All of these steps are basically common practice. They're very common, and my old code was just not meeting any of the standards. This video is only going to focus on improving the data access layer. 70 entities from the old solution need to be rewritten and updated, and Copilot is going to be doing a lot of the manual work. It's going to use a template or some sort of guide that I'm going to give it to follow. Now, let's get started. A quick reminder, I'm building a car classifieds website. It's got a lot of code, and once again, it doesn't need today's coding standards. Specifically looking at the data access, as a very good start that when I started writing this code, I did somehow know about Entity Framework, and in the old version, the last time that I touched this code, it would have been Entity Framework 4. So Entity Framework 4 on the old .NET Framework 4.8. Again, when I worked on this pet project, my skills were just about okay. I wasn't able to handle high-level architectures. So a lot of the code issues are going to show my skill level for the time when I was doing this pet project. I'm using a generic repository, which is a good start, but pretty much that's where the good parts end. Issues with the old code base go beyond Entity Framework or the repository pattern. The first problem, the repository also immediately performs a commit on the insert or update operations, meaning there is no unit of work which does a single commit to the database for a number of commands. One example would be if there are 5 records to insert, each one gets done individually. Basically, expensive database operations would hog and slow down the entire application. The second issue is mixing data access logic with actual domain logic. The main event in the classifieds application is when a listing gets placed. So when a car advert gets placed, the user presses submit. This is going to result in a lot of actions that need to be handled. First of all, it's going to be inserting this new record in a database. That's pretty obvious, straightforward. But now most adverts or listings also have pictures of the car being advertised. Those images have to be saved somewhere. If there is a potential buyer who've also subscribed to alerts for, let's say, a certain type of car, those alerts need to be triggered. If the person advertising the car is using some sort of credits or some sort of payments, the credits are going to need to be deducted. So, looking at this code, it's got all these actions mixed up in the one business logic project. The architecture is not sophisticated enough to scale. Saving images of the advert, sending alerts, and inserting into a database, all of these are different categories of tasks. So now, if we had a large enterprise classifieds, if this was a large application which gets a lot of traffic, most of these actions would be their own separate queue. So we're going to be, the ideal best solution would be to use a superior architecture, which would be to have different processes or queues handling each action. Now, my code is not able to handle a lot of visitors. It's just not sophisticated enough. So the first thing to get right would be the data access code, to pull it out of the business logic project, then also make improvements to this logic. make actual use of the unit of work. So this would be like the most obvious steps in improving the old code. For all entities, the process is going to be the same. Developers all have their own preferred ways of implementing the data access layer. How I have chosen to go about it is to have a data access class for every entity. So this data access class is just basically a wrapper around the repository and unit of work patterns. In super simple terms, all the queries use the repository, and all the commands, basically inserting, updating, deleting, they're going to need the unit of work to almost commit, to just say commit. From this data access class, I also return data transfer objects, meaning I'm not directly returning the entities if the query is going to be used for the front end. Now, all these data access classes need to be registered with a dependency injection container. Also, the data access uses entity framework, which also needs a DB context to be registered. Each entity typically needs to have the database tables configured for the types to map out the actual database table. This is a lot of work just to have one entity to be properly set up. Even years ago, I made it a point to try to record how long each entity goes, how long it takes me to do all of these little steps. And back then it used to take me roughly 15 minutes per entity. Now, again, repetitive donkey work for each entity. It should be automated. So I have this markdown template that will tell any AI model used in Copilot how to implement each one of these entities. All that it would need would be a collection. It will then generate the starter code for the repository, the queries. It will do all of this work where each entity would take me, like I said, 15 minutes. Okay, so now I just have to get the entities from the old code. And in the old code, I want to just simply get a list of all the entities and the columns or properties. This is a lot, 77 entities in total. Even if I don't use all of them, to try and convert this by hand manually if I was to work it out, it would take me about 20 man-hours, meaning it will actually take about 3 full working days, at least if I'm working 6 hours a day. So just to try and do all of this setup to get it to be at a good standard. Asking Copilot to return all 77 entities and their full class definitions, it was basically just politely refusing. And this sort of simple task, the free Grok Code Fast 1 should be able to handle, saving a lot of premium requests. I ended up having to use ChatGPT 4.1, and even after a long time, I managed to get all the entities placed into the files. These are files I would feed Copilot with my entities, just to generate just to get it to generate and recreate the new solution. Here is one example of the entities with the actual class definitions. Before continuing, I will just create a new branch. Now, Copilot has a long list of over 70 entities for which to do a lot of repetitive work. I will test out the code generation with only about 3 entities. As you can see, the solution is still mostly empty, and Copilot is going to create a whole lot of classes for the data access layer. I find ChatGPT 4.1 is quicker than the 5 mini. The only problem is that it asks me for every little permission. Every 5 seconds it has to chime in, and I just wanted it to get on with the job. But I mean, it's fair. It's a previous generation model. It's not really that sophisticated. The process of churning out all these entities and their code needs me to be involved, but only very lightly. It is taking much longer than I estimated. This whole thing took me close to 4 hours. That's because any model that AI I was using, it has to pass, I mean, it's a lot, 77 tables or 77 entities. It has to pass through each one of them and get each property. The process of churning out all these entities and their code needs me to be involved, but only just very slightly. Eventually, I did get this whole thing done, and the final end result is that close to 80 entities, they're organized into some sort of sections or a bounded context, and for each entity, the tedious work of wiring each one of them is done. If we look at listed car as an example, this is the actual entity. If I didn't have Copilot, this would need me to manually copy and paste each version. And like I said, it could have easily been almost a week. Okay, I mean, looking at the rest of the solution, Copilot did all of this work, and this is now a major time saver. So that's going to be it for this video. We're going to continue rewriting this old code base, and we're going to take it from there in the next video.